Welcome to part 2 of our 3-part installment on serial communications, variables, and control structures including loops. This lesson focuses on variables. A variable is a place to store data. They have a name which should be descriptive to help you read your code or even debug your code. They have a type such as integers or strings, we'll get into that later, and they have a value. So if my variable is an integer, it might be 4,000, and if my variable is a string, it might be the letter C. In order to use variables, I first need to declare them. So in my Arduino sketch here, I'm going to go ahead and declare two variables. I'll declare x, which will be an integer, and I'll set that equal to 32,760. And I will declare an integer y. Here I've declared the integer, and I'll go one line later and actually assign it a value. And I want to perform some arithmetic here and look at the results on the serial monitor. So I'll go ahead and print my two variables, x and y, as long as the sum of x and y. To accomplish this, I've written the following code here in my sketch. Here we initialize the serial stream at 9600 baud. We then print the string x equals, followed by the value of x. So whatever's stored in the variable x, that value will be printed to the serial monitor. We then print the string y equals, followed by the value of y. And lastly, we print the string x plus y equals, followed by the summation of the values stored in x plus the value stored in y. So we can go ahead and upload that to our Arduino Uno. And with the sketch uploaded to the Arduino, let's take a look at the serial monitor. And here we have it. X equals 32,760. Y equals 5, and the summation, 32,765. So this bit of code works quite well. Let's now try and print this information over and over and over again in our loop function. So go ahead and cut and paste all of the serial.prints and serial.println segments of code here and put them in our loop function. Now I'll go ahead and compile and upload that to our Arduino, and we have an error. Okay. X was not declared in this scope. This is a compile time error, and the issue here is that x was declared as an integer variable in the setup function. Unfortunately, once we get into the loop function here, this function has no idea what x is or what y is for that matter. So the way to fix this issue is to make x and y both global variables. Let's go ahead and pull those out of our setup function, and we'll put them up top here. So now x is still an integer variable. It's still equal to 32,760, but it's a global variable now. I've both initialized it and declared its value before the setup and before the loop functions here. Now I've declared y as a global variable, so it'll be accessible to both setup and loop, and I can still leave the declaration y equals 5 inside setup here. In fact, I could leave it up top in this configuration, or I could leave it in setup. Let's go ahead then and upload that to our Arduino. And with no compile time errors, let's go ahead and look at the serial monitor. And you'll see now we're printing x equals, y equals, and the summation over and over and over again. And again, I can get out of the auto scroll feature by checking the box or unchecking the box, and if I wanted to, I could add in a delay into my sketch. Now let's change the value of y from 5 to, let's say, 8, and let's go down into our loop function and add a delay here so we can see what's going on with this code. Go ahead and upload that to our Arduino and open up the serial monitor. So what's happening here? X is correctly displayed as 32,760 and y is correctly displayed as 8. But take a look at the sum. X plus y is equal to minus 32,768. That's incorrect. Something's wrong there. Well, this is indicative of the variable type. We've declared x and y as integers. And if I go back to my Arduino language reference page and scroll down a bit, I can click on int here. And what it tells me here is that integers are stored as 16-bit 2-byte values. Therefore, variables defined as integers are only allowed to occupy a range of minus 32,768 to positive 32,767. My code, however, is attempting to add two integers together, the result of which is outside of that range. Fortunately, there are multiple ways to solve this issue. Let's go back to our reference page here. And if we take a look at the different data types, let's click on unsigned int. So variables that are declared as unsigned integers can occupy a range of 0 to 65,535, right? So that would work in this case. We could also assign our variables as longs. And long here, you'll notice, is 4 bytes instead of 2 like the integer, so it's going to take up more memory. However, you have a drastically larger range of numbers which you can occupy, right? So negative 2 billion and change all the way up to positive 2 billion and change. So in our sketch then, let's change both variables from integers to longs. So we'll do long y here and long x, and then let's upload that to our Arduino again. And when we open up the serial monitor here, we see that correctly declaring the variable type associated with variables x and y has solved this issue. And we're now adding 32,760 plus 8, and we're correctly reporting on our serial monitor 32,768 as the summation. Variable types play a role in mathematical operations as well. So take a look at my code here. I've now redefined x and y, they're now integers. I've got x equal to 3 and y equals 7. I've declared an integer z and not initialized that just yet. In setup, I have my serial.begin, I'm at 9600 baud. And now in my loop, I'm printing x and y, and I'm defining z as the product of x and y, and then printing z to the screen. And I have a 1-second delay here so that we can see things more clearly on our serial monitor. Let's go ahead and upload that to our Arduino and open up the serial monitor. And sure enough, 3 times 7 is 21, and we're getting the proper output here. But what if we divide y by x instead of multiplying? Let's update our code to do a division and then upload that to the Arduino. And when I open up the serial monitor, now the Arduino is telling me that 3 divided by 7 is 0, and surely this is incorrect. So the problem here is related to the fact that we've declared z as an integer. And integers are only allowed to occupy whole numbers. So one way to solve this issue is to go ahead and define z as a float, and we'll take a look at this in a second. Now, before I upload, I want you to take note that the original program here is using about 7% of storage space, right? About 2.5 kilobytes. Now, when I upload my new sketch, we see that we're now at a little over 4 kilobytes, right? So we've gone from 7% up to 12% of the available storage space. So let's go ahead and open up the serial monitor and see if that solved our problem. And unfortunately, it has not solved the issue. Let's go back into the code and take a deeper look then. If we go into our loop function here, we see that we're assigning the variable z the result of the integer division, that is integer x divided by integer y. So what we need to do here is actually cast one of these integers as a float. So after uploading my new sketch, I can open up the serial monitor, and now I am correctly reporting 3 divided by 7 is in fact 0.43. So the key here was casting an integer variable, in this case x. I was casting it as a float such that I could correctly compute another float, in this case z. So it's important then to be aware of the types of variables you're using in your Arduino sketches.